Guess who's back? It's another math episode from Mr. Mac. Alright. So, in task number 3, we'll be working with exponents. If you want, you can refer back to your laws of exponents cheat sheet as I go through some of these. So with question number 1, the first situation that we're dealing with is a negative exponent. The rule when dealing with negative exponent is basically a base being raised to a negative exponent, and it's equal to a fraction with the 1 as the numerator and the base raised to the positive exponent as the denominator. So let's break that down. Alright, so when you just think about 6 to the second power, that's equal to 36. So essentially what's basically happened is we're taking that number 36 and we end up with its reciprocal, alright, because 36 is known as 36 over 1, but when we're turning it into a fraction from an exponent, it's 6 to the negative second, and our final answer becomes 1 over 36. When you evaluate these exponents, we want to turn them into a numerical form. Alright, on to question number 2. So in this question, we basically have negative 2 times negative 2 times negative 2. Alright, and it's negative 2 raised to the third power. This deals with a negative base. If a negative base is raised to an even power, it's positive, but when raised to an odd power, like to this number 3, it's going to be a negative answer. Alright, 2 times 2 times 2 gives us 8. So our final answer is negative 8. Now question number 3, a little bit crazy. We have a negative base and a negative exponent. So that negative exponent lets us know we're going to be dealing with a fraction. Alright, we also have a negative base being raised to an even number. So that lets me know that my final answer is going to be positive. On the side, I like to think to myself, okay, what is 4 squared? I know that 4 squared is equivalent to 16. Alright, its reciprocal is 1 over 16 when I get it into its fraction form. Alright, everything except for 0 to the 0 power is equal to 1. So that's pretty easy. And 0 to the 0 power is undefined. Now let's move on to question number 6. Alright, in question number 6, we are multiplying exponent. If the base is the same, we keep the base and add the exponents. 4 plus 7 is equivalent to 11, and we end up with 8 to the 11th power. Okay, question number 7, slightly different. Bases are different, so the answer is exactly the same as such. X squared times y to the 5th power. That's it. Number 8 represents a power to a power. When raising a power to a power, we keep the base and multiply these exponents. So our final answer, when we do 4 times 5, we get 6 to the 20th power. Question number 9, a little hidden. Alright, when you look at a whole number, the invisible number that's written here is the number 1. So again, we're still multiplying exponents. Or we keep the base, add the exponents, and it becomes 12 to the 3 plus 1, and we get 12 to the 4th power. Alright, now when we do the inverse operation, or the opposite, which is division, we end up subtracting the exponents. So we end up with the question that will be w to the 11th minus 6, and that gives us our final answer of w to the 5th power. Okay, same exact thing in number 11. Same base. When we subtract the exponent, we end up with 9 to the 1st power, also known as 9. Alright, so let's scroll on down. 12 through 14. Alright, both of these are negative 5s. Alright, so we have the same base, and when we add their exponents, keep that negative 5 inside of parentheses. 2 plus 7 ends up giving me negative 5 raised to the 9th power. Okay, 5 to the 4th power looks like that. When we express the reciprocal, it becomes 1 over 5 to the 4th power. That's what happens when we have a negative exponent. Alright, 1 goes in our numerator, and it becomes the base raised to the positive exponent. Alright, next we have question number 14, and we have the same base, but on top of that, we need to find the sum of their exponents, and that's equal to 4 to the negative 5th power. And since we're going to be giving you the exponential answer. It becomes 1 over 4 to the 5th power. Question number 15. Circle all the expressions below that are equivalent to negative 36. All right, so a negative 1 times a positive 36 is negative 36. So I like that. Next one, also known as 6 times 6, that's positive 36, so no me gusta. All right, next one. This question is very difficult for some. We have to follow order of operations, or as some of you refer to as PEMDAS. And if we honor PEMDAS, there are no parentheses, but there is an exponent and it's only attached to the 6. So essentially we have the question 6 times 6, and then that will be multiplied by a negative last. 6 times 6 gives me 36. 36 times a negative gives me negative 36. So this one is also correct. All right, the next one is negative 6 times negative 6, because both are enclosed in parentheses. So that's negative 6 times negative 6. We know a negative times a negative is a positive, so that gives us positive 36. So that is not the correct answer. The absolute value of 36 is simply 36. That is not the correct answer. And the absolute value of negative 36 is also 36. So again, that is not the correct answer. Now on to question number 16. So, talking about bacteria can divide every 20 minutes. So one bacterium can multiply 2 in 20 minutes, 4 in 40 minutes, 8 in 60 minutes, and so on. They want us to write the number of bacteria after 60 minutes as an exponent. So the beautiful thing about this question is that directly in the question for 60 minutes, they tell us that the number that they want is the number 8. So they want us to express that number 8 as an exponent. All right, so that number 8 as an exponent, in reference to this question, let's take a look what's actually going on. We started off with 2 bacteriums, then we went to 4, and then we went to 8. So what I normally challenge students to do is think about the pattern that's happening each time. I'm basically doubling. 2 times 2 gave me 4, 4 times 2 gave me 8. Now on the other side, all right, it was 2 for 20. 4 for 40, and 8 for 60. So over here, I'm increasing by 20 minutes each time. So again, over here, we're multiplying by 2. But on the other side, each time, we are increasing or adding 20 additional minutes. So since we're doubling each time, let's find a power of 2 that's equivalent to 8, and that's the number 3. Be careful for questions like these. If they ask you to express it as an exponent, an answer like this is plausible. But if you just write 8, that's not expressing it as an exponent. So please make sure you're paying attention to detail. Now down here, it's slightly different. They're asking specifically for how many bacteria will there be after 100 minutes. So if I follow this trend, all right, I go another 20, I'm at 80. And if I go another 20, I'm at 100. All right, now over here, I got a double. All right, 8 times 2, and then I go 16 times 2. And this would be 2 to the 4th power. Then down here, I end up with 2 to the 5th power, which is equivalent to 32. All right, 32 bacteria after 100 minutes. If you want, you could be awesome and just label it. And that's about it.